Okay. Okay, in the last class, we started trigonometric integrals, the trigonometric substitution, and we solved some of the examples. We did till example number 3. So let's continue with example number 4 is just the U substitution. Let's discuss it here. Okay, let me just write it down here and then. Integral of x over x squared okay, in this example, you can apply the U substitution or the trigonometric substitution. Because if you take U is equals to x squared plus 4, and then you'll be getting du, which is 2x dx, and x dx is equals to du over 2. So you can easily apply that substitution here. And x squared plus 4 will become square root u. Taking half out and writing u half in terms of negative coefficient. Okay, if you add 1 to this and we'll divide that with the 1, so it becomes half over half. Let's see. This half and this half is cancelled out. U was equals to x squared plus 4. Half, let's see. Or we can say this is equals to x squared plus 4 plus c. The other method is that we know that x squared plus 4 square root 2. We can write it in like this, x squared plus 2 whole square. And for the trigonometric substitution, we have to go back to the book. Yes, x squared plus a square. So instead of x, we can write down a tan theta. And our a is 2. Okay. So x squared plus 4 will becomes 4 tan square theta plus 4. Taking 4 out, and inside will be left 1 tan square theta plus 1, and square root 4 will become 2, and 1 plus tan square theta is equals to okay, let's write it as it is. One plus tan square theta is equals to sec square theta, and square root of sec square theta will become 2 sec theta. So integral of 2 sec theta and x is equals to 2 tan theta d theta. Oh, here the answer is in dx form. We have to convert dx into d theta. So for that, we have to differentiate it. When differentiating x becomes dx, 2 is constant. The derivative of tan theta is sec square theta d theta. So instead of dx, I can write down 2 sec square theta d theta. Two is cancelled out with 2. Sec theta is cancelled out with 1 of the sec theta. So 2 tan theta sec theta d theta. Okay, the integral of tan theta and sec theta is so that let's go back to the book. If we can find out some sort of identity there. Instead of tan theta, I can write down sine theta over cos theta. And instead of sec theta, I can write down 1 over cos theta d theta. Sine theta over cos square theta d theta. Taking u as cos theta and the derivative of u is du and the derivative of cos theta is sine theta minus sine theta d theta. So instead of sine theta d theta, I can write down minus du. Instead of cos square theta, I can write down u square. And so it be taking minus sign out and writing u minus 2 du. Adding 1 to the power, so it becomes u minus 1 or minus 1. U was cos theta. And this minus becomes plus. So the answer is 1 over cos theta plus c. Or you can say that 2 over sec theta. Yes. Is it clear?
Yes. Can we solve the examples that are left for 7.3 and then move to 7.4?
Wait 1 minute. Let me just get back to the book. Yeah. What were you talking about?
I mean, can we finish solving the examples that are for 7.3 and move to 7.4?
Let me check it out. What is 7.4? Okay, integration by rational function. I actually haven't revised this topic, but I need to revise this topic 7.4 before I can teach someone.
Okay.
Yeah, because I have studied the partial fractions, but not in terms of integration. So I need to learn first what is it.
Okay, then so today let's just solve 7.3.
Okay, yeah, but we can solve the exercise questions, which are not easier than, because it requires a lot of identities that if we put them correctly, then we are going to solve it. If not, then it's gonna hectic. Yeah.
Okay.
Requires a lot of practice. Okay, so we have done this question. Now we can do this one or this one. This one seems a little bit difficult because it has limits as well. So let's try this one. X3 over 4x squared plus 9. Three by 2 dx. And integration from 0 to 3 square root 3 by 2. Okay. So can I write my denominator like this? X3 integration from 0 to 3 square root 3 by 2. X squared plus 9 by 4 3 by 2 dx. Taking 4 that side of the equation. I mean dividing both sides of the both side by 4. So 4 got cancel out and it becomes 9 by 4. Then 0 to 3 square root 3 by 2 x3 and it becomes x squared plus 3 by 2 square.
Okay, so I think here you just like take something common, which is 4. Or why you divided by 4? To take to have only x alone? Like why we divided by 4?
Yes, we have to take the 4 common. Then we can divide it. Because when we multiply it, it becomes 4x square and 9 plus 9. Yeah, we have to take out 4.
Okay.
So it becomes taking constant out and integrating from 0 to square root 3 by 2 x cubed.
Sorry, we factor or take something common to have x alone, right? Without any number with it.
Yes, because we want to form this form. X square plus a square. So we can apply the trigonometric integration. So it becomes x squared plus 3 by 2 Okay, now get back to the book and find out, because we have plus sign. So we have to apply a squared plus x squared identity, which is this, and trigonometric substitution is x equals to a tan theta. And our A is 3/2 and tan theta, because we need dx as well. So dx is 3/2. The derivative of tan theta is sec square theta. And what else we need? Yeah, we need to put x square plus, can I write this like this? X square plus 3/2 whole square. And then there will be cube root, because there is half which becomes square root, and then there is a cube root, which is the whole cube root. So now this equation has been formed, x square plus a square. I can now easily apply ax is equals to a tan theta. Our a was 3/2 and dx was 3/2 sec square theta. Now instead of x, I can write down 3/2 tan theta whole square plus 3/2 whole square cube root. So it becomes 9/4 tan square theta plus 9/4, and then there is a cube root. Taking 9/4 out, so it becomes 3/2, and inside is left tan square theta plus 1 cube root 3. Okay, so 3 cube root, 2 cube root, and here is 1 plus tan square theta is equals to sec square theta. 3 times 3 will become 27. 2 times 2 times 2 times will becomes 8, and sec theta. Okay, let's just substitute these values, and yes, we have power 3 over sec square theta, because we applied power over cube root over these three, over 3 over 2, but we have to apply it over 2 tan square theta plus 1 as well. So it becomes sec 3 theta. And now our original equation is x cube for x square plus 9 . So instead of x cube, I can write down this value, which is 3/2 tan theta and that is in whole cube divided by taking 4 out, so it becomes 1 over 4. And instead of x square plus 9 over 4 power 3/2, I can write down 27 over 8 sec cube theta. And instead of d theta dx, I can write down this, which is dx equals to 3/2 sec square theta. And yes, we have limits also. Our limits was x1 was 0 and our x2 was 3 cube root 3/2. But now we need our limits in the form of u1 and u2. So our u1 is I mean, we need our answer in theta form, because we are now converting everything into the theta. So we need theta 1, and which is equals to, because x equals to a tan theta. So I know what is x. My x is 0 here. So for finding theta 1 and theta 2, I know x equals to 3 by 2 tan theta, because that's what I assumed. X equals to 3 by 2 tan theta. And my x is 0. So 3 by 2 tan theta. This 3 by 2 is divided with, becomes 0. 0 equals to tan theta. So theta is equals to tan inverse 0. So the theta is tan inverse 0 is 0. Theta 1 is 0. And for theta 2, our x2 is 3 square cube root 3 divided by 2 equals to 3 by 2 tan theta. This 3 cancel out, this 2 cancel out. So tan inverse cube root 3 will be equals to theta. So tan inverse cube root 3 is equals to 60. Or we can say this, it is equals to pi by 3 radians of 60 degrees. So here our limit is 0 to pi by 3. Is it clear?
Yes.
Okay. So 1 over 4, 0 to pi by 3. Okay, 3 and power 3 will be 27 over 8 tan 3 theta multiplied with 3 over 2 sec square theta divided by 27 over 8 sec 3 theta. Okay, this 27 over 8, this 27 over 8 cancel out, and taking 3 over 2 outside, so it will become 3 over 8, 0 to pi by 3. Okay, and this sec square theta is cancelled out with sec cube theta. So it left tan cube theta over sec theta d theta. Okay, now we have to look at which identity that we can use. It is 1 by 4, this becomes 27 by 8. Converting tan cube theta into sine cube theta over cos cube theta. Converting sec theta into 1 over cos theta d theta. Sine cube theta over cos cube theta multiplied with cos d theta. So this cos is cancelled out with this cos. So left with 0 to pi by 3 sine cube theta over cos square theta d. 3/8, 0 to pi by 3. Can I break down my sine cube theta as sine square theta into sine theta d theta over okay, and now I have got sine theta d theta. So sine theta d theta, which I assume that it is du. So my u should be cos theta. So I have to convert this sine square theta to 1 minus cos square theta. Now applying the u substitution, it's become 3/8, 0 to pi by 3. 1 minus u square over u square. Sine theta d theta becomes du. Oh yes, and these limits are still in theta forms, but now I have converted everything from d theta to du, so I need to change my limits as well. So my pi by 3 upper limit becomes u is equals to cos pi by 3, and cos pi by 3 is half, and my lower limit is u1, which is 0, so cos 0 is 1. So 1 to half. Okay, and it becomes 1 over u square minus u square over d. Can I break down my denominator with each term in the numerator? So it becomes 3/8, 1 to half. 1 over u square, it becomes u minus 2. And this is cancelled out, so it left only minus 1. Now adding 1, it becomes minus 1 over minus 1 minus u. A limit from 1 to half. Taking minus sign out, so it becomes minus 3/8, 1 over u minus u, and my u was cos theta. Okay, when I took minus sign out, this should be plus as well, because minus sign is with both of the terms. So taking minus sign out, it will be plus here. Now just we have to apply the upper limit and lower limit and have to simplify the answer. Is it clear? Hamda, is it clear? Hello?
Yes, I did hear it was lagging.
Your voice is not clear.
I said that I couldn't hear you, it was lagging. Hello?
Yeah.
Can you hear me?
Yes, I can hear you.
Yes, I said that I couldn't hear you, your voice was lagging.
Oh, I'm sorry about it. Okay, so
No,
let
did you ask something at the end?
yes, I
I heard
asked
the
you that
explanation.
you heard the
Yes,
explanation, right? I was asking you if
yes.
the last step is just we have to apply the upper limit and lower limit and then just have to simplify it using the calculator. So is this question, I mean, the techniques that we have used to get the answer, applying the U substitution and then trigonometry integrals, is it clear? Because that's the main part.
Yes, it is clear. Thank you.
Okay. So let's get back to the now exercise question. Again, the question number 1, 2, 3, they have given us that what is our, but it's not necessary that they should mention it. We know that it is 4 minus x squared, then we have to apply this integration. Or I mean this substitution, when it's x squared plus a squared, then we apply it with 10, and if x squared minus 4, then we apply this. Let's do question number 4 then, where we have to ourselves identify what is our which identity that we have to use to simplify our answer. So it was exercise question number 7.3, exercise question number 4. Which is x squared 9 minus x squared. Okay, it is 9 minus x squared, so I can write it down is x squared 3 squared minus x squared dx and my 3 square and minus x squared, the identity that I will be using is this one, a square minus x squared, which is equals to a sine theta, x equals to a sine theta. And my a is 3, so it becomes x equals to 3 sine theta. And my dx will be 3, and sine theta will become cos theta d theta. Okay, so now I have got dx, I have got x. Let's first simplify this part. So it is 3 square minus x square whole square root. So it becomes 9 minus x square is 9 sine square theta. Taking 9 out, so it becomes 3 outside the square root. It becomes 1 minus sine square theta. And I know that 1 minus sine square theta is cos square theta, and outside, okay, it becomes 3 cos theta. So it was x square, which is 9 sine square theta over, instead of 3 square minus x square, I can write down 3 cos theta d theta. Instead of dx, I have to write down 3 cos d cos theta d theta. this three is cancel out. This cos theta is cancelled out with this cos theta. So only left with 9. Taking 9 out, it becomes sine square theta d theta. Okay, now here comes the substitution part where I have to integrate sine square theta. I know that direct integration of sine square theta is not possible, but we know an identity that is half angle identity, which is sine square theta is equals to 1 minus cos 2 theta over 2. So it becomes, taking half out, so it becomes 9 by 2, and inside is left 1 minus cos 2 theta d theta, 9 by 2, and the integral of 1 is theta minus integral of cos 2 theta is sine 2 theta divided by 2. Nine by 2 theta minus sine 2 theta over theta plus c. Is this question clear to you?
Yes.
Okay. Okay, which question we should do? Can we do question number 16? I think that is the lengthiest one. Seems me like a lengthier one.
Didn't we solve similar to this one?
I think we have done in the example question, but that seems to be much simpler than that one because it has a power
Okay, then let's solve 16.
of, okay.
Thank
So it's integration from square root 2 to square root over 3 to 2 by 3, and then dx over x5 plus 9x square minus 1. Okay. Okay, so instead of square root 2 by 3, dx over x5 x square minus 1 by 9. I mean taking the 1 out, 1 over 9 out. Only writing this part here because dx over x5 and taking 9 out. Okay, so inside it will be left x square minus 1 over 9. So it will become dx over x5 and 9 becomes 3, and inside will be left x square minus 1 over 9. Is it clear? And taking 1 over 3 out, so it becomes dx
Yes,
over
yes. It's
dx
clear.
over x5 x square minus 1 over. Okay. Now we know that it becomes our x square minus a square identity, and my x square minus a square is equals to a sec theta. x equals to a sec theta. And my dx will become, okay, my a is now 1 over 3. So it becomes 1 over 3, and the derivative of sec theta is sec theta into tan theta d theta. So okay, instead of dx, I have got x. Let's try to solve this one, which becomes x squared minus 1 over 9. So it becomes x is 1 over 3 sec theta. So it becomes 1 over 9 sec square theta minus 1 over 9 whole square. Taking 1 over 9 outside, so it becomes 1 over 3, and inside will become sec square theta minus 1. And I know that sec square theta minus 1 is equals to tan square theta. And so taking square root of tan square theta, it becomes tan theta. So this thing is equals to tan theta, 1 over 3 tan theta. And dx is 1 over 3 sec theta into tan theta d theta over x5, which is 1 over 3 sec theta whole power 5. And then x squared minus 1 over 9, I can write down 1 over 3 tan theta. Now we have to cancel out. Okay, let's first simplify. 1 over 3 sec theta tan theta, and 1 over 3 power 5 is 243 sec 5 theta 1 over 3. This tan theta is cancelled out with this tan theta. The sec theta is cancelled out with this sec 4 theta, or becomes of sec 4 theta. And yes, this 1 by 3. Can I cancel 1 over 3, 1 over 3? And taking 1 over 2 by 2, 4, 3 outside. So it becomes 243 multiplied. Inside will be left 1 over sec 4 theta d theta. 3 goes into 243 by 81 times. Okay, and we had some limits as well, 2 by 3 and square root 2 by 3. So these limits were in the form of x. We have converted now everything into the theta. So my theta 1 will become here, x was 1 over 3 sec theta. The upper limit is 2/3. These threes cancel out. So sec theta is equals to 2. Okay, and this sec theta is equals to 1/cos theta 2, or I can write out cos inverse equals to 2. So theta equals to sec theta is equals to 2. Pi by 3. Another theta is, x1 is square root 2 by 3. Is equals to 1/3 sec theta. This 3 is cancel out. Sec theta is equals to square root 2. So sec 3 square root 2 is equals to theta is pi by 4. 45 degree or 60. Now our new limits will become pi by 4 to pi by 3. Now we can't directly apply the integration on 1/sec 4 theta. We have to apply our some trigonometric identities that we learned yesterday. So it becomes pi by 4 to pi by 3. Can I write my sec 4 theta like sec square theta multiplied with sec square theta? And sec square theta is tan square theta minus 1 d theta. Did you realize that we can't now apply the u substitution here? Because
Yes.
If I take my u as 10, then my d theta is in numerator side. So I can't apply u substitution here. From here, I have to find out some other identity. So it becomes okay. Let's convert it into the sine and cosine form. So let's see if I can apply, if we can apply the identity. So 1 over sec 4 theta, can I write cos 4 theta d theta, because sec theta is equals to 1 over cos theta. So 1 over sec theta is equals to cos theta, and there is in a power of 4, so it becomes cos 4 theta. Now I can write it in this form, cos square theta and cos square theta d theta. Now converging one of the cos square theta into sine square theta, I mean 1 minus sine square theta d theta. Then still the same situation here, because we have cos square theta here, not cos theta. Okay. The last option that is left, because we can't apply the u substitution here. We have to apply the double angle identities for cos square theta. So for the double angle identity for cos square theta is 1 plus cos 2 theta over 2. And cos square theta is 1 plus cos 2 theta over 2 multiplied with the theta. Taking 1 over 2 outside and multiplied 1 plus 2 cos 2 theta plus cos square 2 theta. Taking this constant out, so it becomes 1 over 4. And 4 goes into 81 by 27 times. So 1 plus 2 cos 2 theta plus cos square 2 theta d theta. Now it's easier for us to apply the integration here, because we know the integration of 1. We know what is the integration of cos square theta, becomes sine 2 theta over 2. And here we again have to apply the identity, double angle identity, which was we used this identity yesterday. Here it was cos square theta 2 theta. Here cos square 2x, here we have cos square 2 theta, so it becomes 1 over 2, 1 plus cos 4 theta. Okay, so applying that identity here, and now because that angle is in double angle identity, so we can easily apply the integration, and now we have to apply only the limits. Is it clear?
Yes.
Okay. Should we solve it further, or if it's clear for you, then we can end it here.
Yes, it's clear.
Okay. This question was so lengthy.
Yeah. I don't think that this might come in the exam.
Yeah, but
Because it's
yeah,
too-
but actually the thing is that we should learn the technique. So if we learn the
yes,
techniques,
because
then
it includes everything.
yes, this question includes everything.
Hmm.
This question and one of the example question that we did today, that includes everything. So do we have a session tomorrow?
I don't think so. Tomorrow I have university till 5 p.m.
Okay.
On Thursday, I think I'll be available. I can take a class.
Okay. On Thursday, just confirm in the morning. I mean on the Thursday, because
Okay.
I have one of your friend class as well, so I have to see the schedule as well.
Okay. Is she taking it like the same time or?
No, 1 hour after your class. I mean 6:30. Your 7:30, my 6:30.
Okay. I'm 4:30, me, right?
Your class is at, yes, 4:30 to 5:30 in your
4:30.
time zone, and my time zone it is your 5:30 to 6:30.
Okay. Okay.
Yeah.
Okay, then I will confirm on Thursday morning.
Yeah, sure.
Thank you.
Yeah, bye. Anita.